Okay, for this block lecture, we are going to be talking about different ways that we have been mapping and measuring the Earth's surface. So we will be covering topics of early Earth measurements. We will be covering latitude and longitude and identifying the difference between the two and how they're used to define a point on the Earth's surface. We will be talking about time zones, identifying great circles, and talking about maps, map scales, and map projections. So the image that we see here on our screen is defining the equatorial circumference, the distance around the equator. Now the equator is a line of latitude that directly divides the northern and southern hemisphere in half. And so we call that the equator. Now the equatorial circumference is measured at being 24,902 miles around. We can also describe it in kilometers, 40,075 kilometers. Now we can define the polar circumference, so basically the distance around from pole to pole, as being 24,860. Now you may decide that the two numbers do not match up. Well, that's because the Earth is not a perfect sphere. Now, when we talk about the Earth and the science that tries to quantify the Earth's size and shape, this is called geodesy. And when we talk about the Earth not being a perfect sphere, we talk about this as being a geoid, which means it's not perfectly spherical. Now, the Earth itself has an equatorial bulge that takes place. So you can see on the screen that a perfect sphere would represent the dashed, dotted, black line that we see here. But we know that's not the case because the polar circumference and the equatorial circumference do not line up. Now, we know that early Earth measurements took place back around 500 BC. So, for example, Pythagoras wrote about the Earth as being a sphere. The first recorded physical evidence of having the concept of the spherical Earth was by Aristotle around 350 BC. And Eratosthenes was the first to calculate the Earth's circumference in 247 BC. So how did we know the Earth was round without using modern instrumentation? So Aristotle identified 3 celestial observations that were made during the 4th century BC. Now, celestial meaning these are observations by the stars and the sun. So he observed, his first observation was that as ships sail away in the distance, they start to disappear hull first. So the body of the ship disappears, then you start to see the mast disappears, and eventually the sails and the crow's nest. So this was something he observed. The second observation was that a circular shadow would appear, and it would always be cast by the Earth on the moon during a lunar eclipse. So that circular shadow was an observation that came to the understanding that the Earth was this sphere. And the northern and southern stars were not stationary when travelers moved from place to place, so that new stars would appear to the north or disappear to the south as ships were sailing and as folks were traveling. So celestial features that early explorers and navigators used in the northern hemisphere, we call this star the North Star or Polaris, which was used for early navigation and still is used today. In the southern hemisphere, we identify this star as being the Crux Aurelius, or the Southern Cross. Okay, so now we're going to talk about the history of calculating the circumference of the Earth and how Eratosthenes went ahead and did this. So this story takes place in Alexandria, which is at the mouth of the Nile River. Here's the Mediterranean Ocean right here. And in introducing Eratosthenes to you, he was a librarian in Alexandria, Egypt. He was also a geographer. And being a librarian at this hustling, bustling mecca of travelers coming in and out with information, he continued to collect information from different places and different people around the world. So he was this true kind of investigator geographer by the means of the information that he collected. So Eratosthenes is credited for calculating the equatorial circumference of the Earth. And so this is the process behind how he did it. So Eratosthenes knew that on the summer solstice at local noon on the Tropic of Cancer, which is a line of latitude, which we'll talk about, the sun would appear at the zenith, so directly overhead. So he observed the sun was almost overhead on June 21st in Alexandria. So our textbook shows us Alexandria located right here. And we can see that the arc shape of this image represents the Earth's surface. So although the same thing was not an observation in Syene, which was just north of Alexandria. So there was something a little different. So he heard that the sun was directly overhead in Syene, which is approximately 5,000 stadia away. Now that represents about 500 miles. So he knew that, Alexandria was slightly north in Syene, and there was an actual well in Syene that the sun appearing directly overhead was shining at the bottom of this well. And so this was implying that there was this vertical exposure of the sun that shone right overhead on June 21st. That's not the case that took place in Alexandria. So he measured the angle of an obelisk, so like a sundial in Alexandria, so that the shadow of the sun that was almost overhead but not directly overhead was about 7 degrees and 12 minutes, the angle of a circle. So you can see that the interior angle of that shadow measurement is represented right here as 7 degrees and 12 minutes. Now, he was able to, because he knew the distance between Alexandria and Syene, he was able to calculate that distance as being 1/50th of a circle. Okay, now, so there's some units in here that are a little new to us. So for example, a stadia, that's a new term. So a stadia is a unit of distance that was measured in early times because it would represent the distance that one could travel in a stadium. Okay, so we're able to convert what was a distance that was measured stadia, we're able to convert that into modern measurement in distance today as 500 miles. Now, so he was able to take the 1/50th of a circle and multiply it by the distance, 5,000 stadia, and he was able to come up with 28,400 kilometers or stadia distance, which represents a statute mile. Okay, so if you think back to the circumference of the Earth that we talked about, it was relatively accurate way for him to calculate the circumference of the Earth's surface. Now, so the 252,000 stadia that was calculated, if we were to convert that in values, we would get that the corresponding Eratosthenes circumference is between 39,690 and 46,620 kilometers. So the circumference of the Earth around the poles is now measured at being about 40,000 kilometers. So Eratosthenes' result that he calculated was not that bad at all in comparison to using, early techniques and observations at this period of time. Now we can see another image that helps define how Eratosthenes was using the scientific method of observation, data collection to measure the obelisk at Alexandria, to measure the inverse angle of 7.2 degrees, then applying the distance of 5,000 stadia as an arc, making up an entire circle, to be able to calculate the circumference of the Earth. Now, I really like this image because it allows you to see geographically where Alexandria is located for lines of latitude at 31 degrees and 13 degrees north, minutes north, and Aswan, which is referred to as Syene at that period of time. Now, if we were taking the measurements along the Tropic of Cancer, okay, which is just south of Syene, the sun would be completely overhead, and we will talk about that in the following slides. Okay, so we identified geography as describing the why of where. Okay, so when we talk about where, we need to have a mechanism to measure and define a location on the Earth's surface. And we do this by using latitude and longitude. So latitude is the angular distance north or south of the equator, measured from the center of the Earth. Okay, so when we talk about the angular distance, we're talking about coming to the center of the Earth, having a parallel line that comes out to our equator, and then having a line that represents an angle of measurement. So for example, if we took this line of latitude and followed it all the way around, this would be representing 49 degrees latitude because it's the angular measurement in which it's showing. So as I mentioned earlier, lines of latitude divide the Earth into equal sections, the northern hemisphere and the southern hemisphere. And the equator is defined as 0 degrees. So we have sections in the northern hemisphere that are described as 23.5 degrees north, 49 degrees north, 90 degrees north. Now the same thing can be said in the southern hemisphere where we can have 23.5 degrees south, 45 degrees south, and 90 degrees south. Okay, and we often define lines of latitude as parallel lines. Now, when we talk about latitude, we can identify latitude in regards to geographic zones. Now, we can define latitudinal regions by geographic zones in which we observe changes on the Earth's landscape. So, for example, between 0 degrees or between 23.5 degrees north to 23.5 degrees south, we define this region and this zone as the equatorial and tropical zone. Now, we can define a subtropical zone just north and south of the equatorial zone, and the lines of latitude defined here is 23.5 degrees north to 35 degrees north and south. Now, we will be talking about weather circulation and why certain land features such as deserts form where they are. And the subtropical area is where predominantly most of the Earth's deserts reside. We can also identify the mid-latitudes as being between the latitude lines of 35 degrees north to 55 degrees north and 35 degrees south to 55 degrees south. This is the latitude region in which we live in. We live in the mid-latitude. Above the mid-latitude, we have the subarctic and the subantarctic. So at 55 degrees north and south to 66.5 degrees north and south. And we actually can identify significant lines of latitude at various points. So for example, the Arctic Circle and the Antarctic Circle is defined at 66.5 degrees north and 66.5 degrees south. At the very top, between 66.5 degrees north and south to the North Pole at 90 degrees north and south, that represents our Arctic and Antarctic geographic zone. So if I ask you what is the range of latitude, it's going to go from 0 to 90 degrees north or 0 to 90 degrees south. That's the angular measurement of latitude. That's the range of latitude that we use. Now, those significant lines of latitude, we've already talked about 2 of them. We have our equator, which again separates the northern and southern hemisphere. We have our Tropic of Cancer, which is at 23.5 degrees north, and our Tropic of Capricorn, which is at 23.5 degrees south. And then we have our Arctic and Antarctic Circle. And so now we can go ahead and talk about lines of longitude. Now, lines of longitude are the angular distance east or west of a point on the Earth's surface. So it's measured from the prime meridian. Now, one thing to keep in mind, and this is kind of a little rhyme that I always say to myself, is that lines of longitude are long. Okay, so lines of longitude run north and south, but they're measuring east and west. So for example, 30 degrees west would be a line of longitude. 30 degrees east would be a line of longitude. We can also identify the fact that lines of latitude were much easier to define and recognize in early navigation, and they appeared on maps much sooner than lines of longitude. Now, the reason because of this, lines of latitude and areas of latitude, you can see patterns on the landscape, such as changing vegetation, weather patterns, but lines of longitude are something that was invented by the ability to measure time as ships are sailing on the ocean. So lines of longitude were something that happened later on, was invented later on in the geographic history that helped to define a location. Now, we call lines of longitude meridians. Now, when combining latitude and longitude, you get a grid-like system that helps define a location in the northern or southern hemisphere or a location in the eastern or western hemisphere using longitude. So to define a location on a map, you need both latitude and both longitude. So significant lines of longitude. We have the prime meridian, which is the equivalency of the equator. So for longitude, it's 0 degrees. And again, it basically divides the western and eastern hemisphere. If you follow the line 0 degrees, the prime meridian, all the way around the Earth, on the opposite end, you will find the international date line. So the prime meridian represents 0 degrees, but then on the other side, it represents 180 degrees. So lines of longitude, the value and measurement of lines of longitude goes from 0 to 180 degrees. Now, this is different than what we know of latitude. Latitude goes from 0 to 90 degrees. Okay, so now we're going to go ahead and talk about time zones. Now, modern international time zones are used to help define certain periods of time in various regions around the globe. So the numbers along the bottom of this map represents how many hours each zone is earlier with the plus or minus sign. And it's using the Coordinated Universal Time, UTC, which is the standard time off the prime meridian. So for example, the United States has 5 time zones, and we can see that the United States is divided into 5 colors. So we have our Alaskan, Pacific, Mountain, Central, Eastern, Atlantic time zones. Now you can see that Canada is divided into 6, and we have areas of island nations that are divided into their own time zones as a whole. We have, as you can see, there's the international date line for as it pertains to time zones is not a straight line itself. And the reason why this is because it's more of a cultural line, so that certain islands that are right next door to each other, located close to each other geographically, are not in different time zones. And so when looking at the different time zones, you can see that this is a way to break up the Earth itself into 24-hour days, so providing times on which hours will change. I will point out that there's one very, very large country on here that only has one time zone throughout the entire country, and that's China. So you can see that the color of China is yellow, which is representing that -8 at the bottom of that chart there. And so this means that, China being a very large country is all under one time zone. So in Western China and Eastern China, it's the same time. So for example, it still may be sunny at 8 p.m. in Western China, but it will be completely dark at 8 p.m. in Eastern China. So we also have other things to talk about that is in relationship to time and light. Another topic to touch upon is the daylight savings time. So in many countries, time is set 1 hour ahead in the spring and is set 1 hour back in the fall. And so this is known as the practice of daylight savings time. And so the idea of this, and it was actually proposed by Benjamin Franklin and wasn't adopted until World War I, and again in World War II, when Great Britain, Australia, Germany, Canada, and the United States used to practice this effort to save energy with one less hour of artificial lighting needed. So in the beginning of 2007, the United States increased daylight savings time. So time spring forward 1 hour the second Sunday in March and falls back 1 hour the first Sunday in November. And so we can see that as a whole, you can say that the time zones are kind of a cultural feature that countries can choose to be a part of. Larger countries are broken up into more time zones depending upon how significant they are in size. However, countries can also opt to be in the same time zone, so it's subjective. Now, I want to point out that the features that we talked about were for latitude and longitude. These are not subjective. These are measurements, angular measurements that help define northern and southern hemisphere, western and eastern hemisphere. Now, we can identify some key terms, such as lines that equally divide the Earth in half, and these are known as great circles. So, for example, the equator at 0 degrees is a perfect example of a great circle. A great circle means that it dissects the Earth completely in half, divides it in half. And so the only line of latitude that's a great circle is the equator, because if you look at other lines of latitude, if you pick 23.5 degrees north or 23.5 degrees south, it doesn't equally divide the Earth in half. So those are referred to as small circles. So there's, as I said, there's only one line of latitude that's identified as a great circle. However, if you look at longitude line, you follow one line all the way around, and every longitude line divides the Earth in equal portions. So you could say that all longitude lines are long and they're great circles. So we have a great definition of a great circle, equally dividing the Earth in half, and then small circle. These are going to be points that you're going to want to put in your notes and be able to define. So now we're going to go ahead and move into map scales and projections. So how many of you guys like maps? So based on the introduction of yourself in this class, I felt like there was a common theme amongst everyone's kind of introduction. You all like to be outside. You all have a hobby that's such as hiking, fishing, biking that takes place. Well, those hobbies are associated with some sort of map. So whether or not we know that we use maps or we know that we love maps, we know that maps are there and they are a handy tool. So maps help us depict spatial information and allow us to examine spatial relationships. So we're going to talk about the basics of maps. So certain basics that we know is that, we know that the map is not a true representation of the Earth itself, right? We know that it's a reduced depiction of the Earth. And we know that there's a scale on that map that helps us define the size of things on that map as it pertains to the real world. So a scale is a ratio that relates the image on the map to the real world. We know that maps have projections, meaning that the different ways in which the information is displayed on the map is going to be dependent upon where we are on the Earth's surface and what type of information we're showing. So a projection is the reduction of the spherical Earth onto a flat map. Okay, so again, we're taking this three-dimensional Earth and we are putting it onto a flat surface. And so that's referred to as projection. When we define scale, there's three types of scales that we can talk about. The first one is a written scale. The second one is a representative fraction, which has no units. And the third one is a graphic scale. Okay, so a written scale, for example, is actually writing out what the scale is. So for example, 1 inch equals 4 miles. And it's handwritten out. Typically you find this kind of more on historical maps. Usually it's written in a nice cursive font. The second type is a representative fraction. Now, one thing that's unique about this is unitless. So for example, 1 to 250,000. okay, or 1 over 250,000. So this is a fraction. Now the 1 represents the map, and the 250,000 represents the measurement that's on the Earth's surface. So for example, 1 inch on the map represents